Learning how to use the diagnose debug flow is absolutely important for anybody working in the FortiGate environment. And this is true whether you're just starting out with the FortiGates as a technology or whether you have decades of experience working with these firewalls. Learning how to use this command, but more importantly, learning how to interpret the type of output that you see on the console after running the diagnose debug flow is absolutely important. And I believe that diagnose debug flow is quite possibly the only command you need in relation to troubleshooting VPN connectivity. And this is what this lab is all about. I have a VPN tunnel between between a FortiGate firewall. So our topology is like this. We have a Palo Alto on the left-hand side with the interface address 172.168.100.2. It's facing the FortiGate at 172.168.100.1. And of course, on the public internet, these could be any IP addresses. So the phase one config looks like this here on the screen. We have the PSK of Fortinet. We have encryption. We're using DES SHA-512 for our hashing algorithm, and we are using Diffie-Hellman Group 20. So the config is the same on both the Palo Alto and on the FortiGate, and our tunnel is working. And just to show you that, and just to demonstrate, there's our tunnel. And I'm going to go into the console. I'm logged on already onto the Palo Alto. Show interface all. We can see we have two IP addresses. This is the external interface facing the FortiGate, and this is the network on the inside of the LAN side of the Palo Alto. So what I've done is just created a loopback interface to be able to simulate. And then when we look at our VPN, show VPN, like SA. I believe it's gateway FortiGate 01. So I've called our gateway FortiGate 01 just for simplicity. And yes, we can see that our tunnel is up. It's in the established state. And here's our phase one material. We're using PSK, we're using Diffie-Hellman Group 20, DES, SHA-512, and so forth. And when we ping on the FortiGate, let's maybe have a look at the FortiGate diagnose IP address list. So on the FortiGate side, we have 172.168.100.1, the interface that's facing the Palo Alto, and then on the inside network, we have the 10.160.100.100. So this is the IP address that we're going to ping from the Palo Alto, and let's do that. Ping using the source 10.10.10.1, pinging host 10.160.100.100. And now when we go back to the FortiGate and under monitor, we saw that initially we didn't have any packets traversing the tunnel interface. But now when you look, you'll see that we've got incoming and outgoing traffic. And it's incrementing. So I'm going to leave this working. I'm not going to do anything on the Palo Alto. Most of our work is going to be on the FortiGate. So firstly, we know that we have two firewalls that are communicating. We know the IP addresses. The correct IP addresses is supposed to be 172.168.100.2. This is the remote side. And on the local end, we are 172.168.100.1. Let's start our debug. Debug application, Ike, -1, diagnose, debug, enable. I'm not going to use any filters or anything like that. Okay, so on a normal, good working IPsec tunnel, the two firewalls will be talking to each other. You'll see here we've received informational request, and then we sent informational response, and there's an exchange. We received informational request, and we're sending informational response. So our tunnel is up. The traffic is going over the tunnel. So what I'm going to do is I'm going to change the IP address of the tunnel peer, meaning of the remote end. The address that we have configured here is .2. I'm just going to change this. Let's say maybe there's been a typo, and I'm just going to change this to .20, and then watch what happens on the FortiGate. I'm just going to leave this just so that we've got more output so that we can see repetitive pattern. And I believe we have enough. I'm just going to stop. Diagnose, debug, disable. Okay, so let's go back to the diagram and just understand. We are going to be sending IKE messages to the new IP address. Let's say we made a typo to .20 as we saw in our config. We're going to send to .20, but we expect that we're not going to see any response coming from .20. Instead, we're going to see inbound messages from 100.2, and our IPsec tunnel phase 1 will remain down. So firstly, let's validate this. Is traffic still propagating? No, traffic is not flowing over that interface. And so we know that there's something wrong. And now looking at the output that we got, this is the SA init. And then we're seeing almost immediately we're sending a retransmit of the SA init. And then if you scroll down, you'll see there's another retransmit and yet another retransmit. So what's going on? We know that we're transmitting to 100.20, but we're not seeing any inbound traffic from 100.20. But hang on, if you look closer, you'll see that there's these entries here that say comes 172.168.100.2 into 100.1, and that is an exchange of the SA init, and we can actually see that package being broken down. We can see that it's an incoming proposal. We can see it's got a proposal ID, it's got IKE version 2, it specifies all the phase 1 parameters, but we are not talking to 100.2. Instead, we are talking to 100.20. Now, this is a mismatch. And if you know your network, if you know the parameters of the other end, you would have the IP address of the tunnel endpoint. And then from here, it's easy for you to validate, to see what is the difference between 100.20 and this 100.2. Which one of these is responding? Exec ping 172.16.100.2. 100.2 is responding, and let's check 100.20. 100.20 is not responding. So if you go back to your documentation, maybe your email, maybe you get on a call, you speak to the engineer on the other end, then you validate that, oh no, the tunnel endpoint is 100.2. Then you go back and fix your config. And the moment you fix your config, we are looking at the diagnose debug flow, and we've just enabled the debug. We're back to a healthy communication where there's informational request, informational response. So the tunnel is up. Now let's have a look on the Palo Alto. We can see that the traffic is flowing again. Our ping is getting a response. Okay, so for our second scenario, I am going to break the authentication. I'm going to change the PSK. Let's go to our VPN interface. Just something random, and before I press enter, I'm going to start our diagnose our debug. Diagnose debug application IKE 01. Diagnose debug enable, and then I'm going to press OK. And then watch what happens on the screen. So immediately our terminal starts, and we can see that there's a lot of messages. We can see it says phase 1 down, phase 1 down, and we can see no suitable IKE SA. And at this point, the thing that should stand out immediately to you is authentication failed. Initial contact being sent, authentication is sent, authentication is received from the remote end, and there's a bit of IKE version 2 exchange over there, and we can see that the initiator has received authentication message from the remote side, and it says authentication failed, simply because our authentication parameters and your authentication parameters are completely mismatched. Therefore, we cannot stand up this tunnel. So this is actually all I can think of that would stand out for you in troubleshooting to be looking out for in order to fix phase 1 authentication issues. And what's going to happen now is I'll type the password. Watch the screen. Our ping started continuing again, and if we look, we're seeing again normal messages. I think we missed the part where authentication was accepted. I don't think we can see it because I started this a little bit late. So, but we can see this informational request, informational response, informational request, informational response, and our network is up because the ping is getting a response from the far end. Between the two firewalls. So that is the PSK. For our second scenario, let's break the hash. I'm going to change this to MD5. And then watch what happens. Okay, so we've got a bunch of output here, and immediately you can see that we have some output here. And the thing that you want to do is to compare the incoming proposal with my proposal. So this is coming from the Palo Alto, and this is what's configured on the FortiGate. So without going line by line on each of these config parameters, let's have a look at our SHA parameters. And our SHA hashing parameters, here it says SHA 512, and here it says MD5. And we know this to be true because we broke it. But the thing, I guess, is when you get an output like this, you are then able to compare the values from the remote peer that you're receiving versus the values that you have configured locally on your own firewall. So let's go back and fix. We fix this back, and we watch if the traffic starts flowing. And before long, the traffic does start flowing. And so that concludes the next scenario. And now we could actually also do another thing. Let's change another value. Let's use a different Diffie-Hellman group, for instance. Here we've got 20. Let's change that to 31, for instance, and then watch what happens on the FortiGate. Okay, so we are seeing some output now, and once again we're seeing parameters, the IKE messages from the remote side incoming proposal, and when we go through the config parameters, we can see that they have DES and we have DES, and the Diffie-Hellman group is ECP384 and our Diffie-Hellman group is curve 25519. So what's mismatched in this case is our Diffie-Hellman group, and we know this to be true because we purposefully broke it, but this is a good indication of how you can find issues with mismatched Diffie-Hellman groups. So let's go back and fix that. And the moment we do, we expect to see our ICMP traffic flowing. And on the FortiGate, I expect to see the good behavior of IAC phase 1 that we know, informational request, informational response, and that kind of thing. And we know our tunnel is working because we are receiving good communication from the far end. Okay, so now the last scenario that I want to demonstrate is, say, for instance, there is no firewall policy permitting the traffic. And for that, we need to find the firewall policy that's responsible for allowing this traffic. And I believe it's this policy over here. I'm just going to disable it. I'm going to reset this and then just restart the filter again. Diagnose, debug, flow filter with the address 10.10.10.1. So I'm doing this on purpose because I'm specifically looking for traffic coming from 10.10.10.1. Okay, so I changed the diagnose debug flow command a little bit. The command I'm using now is diagnose debug flow filter address 10.10.10.1. So because this command will give us traffic specific to this address, and the output will have some reference to that IP address, and we want to see why is it that the traffic coming from 10.10.10.1 is not reaching its destination, and why we're not seeing traffic. Because if we look at the VPN tunnel, here you'll see that the tunnel's in the up state, and when you refresh, you'll see that the counters are not incrementing. 45, 16, 45, 16. So although the tunnel is up, we are waiting for connection, we are listening, we are ready to accept and process the VPN traffic, but there's no traffic coming. And looking at this output, the thing that immediately stands out for me is failed. And when you actually look closer, you can see that it says check failed on policy 0 drop. So this is very clear that our traffic was dropped by firewall policy. And so even though the IPsec is in place and properly configured, the routing is in place, properly configured, we can see that the traffic from 10.10.1 going to 10.160.100.100 is being dropped because it doesn't have policy. Policy 0 essentially means that there's no policy. And we know this to be true because we disabled the policy. Now let's enable the policy again. And when we do that, we expect to see traffic starting to flow again. And our ping continues. So if you're still watching to this point, I'd like to thank you for supporting the channel. It means that you found this content useful. Thank you so much, and catch you in the next video.